Okay, our learning targets today are I can make inferences about a data set by looking at the distribution of a box and whisker plot. When making a box and whisker plot, the data is split in half at the median. So I've already organized these numbers from least to greatest, and right in the middle is the median. That splits the data in half. Then each half is split in half again at Q1 and Q3. So if I'm looking at the lower half of data, I split it in half again, and that is Q1. And the upper half of data, I split it in half again, and that's Q3. So the data is split into 4 quartiles, each of them representing 25% of the data. If I take this data from above and I put it on a box and whisker plot, this is how the box and whisker plot would look. This whisker would be 25% of the data. This section of the box would be 25% of the data. This section of the box would be 25% of the data. And this whisker would be 25% of the data. And you might be saying, they don't look the same. There are some sections that are really long and there are some sections that are really short. How can they both be 25% of the data? This section's really long or longer because the numbers in that section are more spread out. But still 25% of the data is in that section. This section, for example, is really short. And it's because the numbers in those sections are really close together. They're all 14 or 16. So that section's really condensed, but it's still the same amount of values. The graph below displays the amount of TikTok videos Esther watched each day in the month of April. Please label the whiskers 25%. This section of the box is 25%. This section of the box is 25%. And this upper whisker is 25%. The median amount of videos watched was, the median is always the line that goes through the box plot. In this case, it's at 16. The median of the lower half of data is, the lower half of data is this 50%. The median of that is Q1, which is at 14. The median of the upper half of data is, the upper half of data is this 50%. The median for the upper half is Q3, which is at 20. The least amount of videos watched was the minimum, which is 10 videos. Okay, on the next slide, we're looking at the same box and whisker plot. Please label each quartile as 25% again. How do you find the interquartile range? The interquartile range is the length of the box in the box and whisker plot. And to find the interquartile range, you take Q3 and you subtract Q1. So we're going to say you do Q3 minus Q1. So what is the interquartile range of this data set? Well, Q3 is 20 and Q1 is 14, and 20 minus 14 is 6. Emily says that the median is always within the interquartile range. Is she correct? So the median is always the line at Q2 that goes through the box. Is the median always going to be within the box? Yes. Yes, Q2 always falls in between Q1 and Q3. Okay, same box and whisker plot. Please label again each quartile as 25%. The middle 50% of videos falls between blank to blank. Okay, the middle 50% would be these two sections. They're in the middle and they add up to 50%. And those two sections fall between 14 and 20. So the middle 50% is between 14 and 20. The lowest 75% of videos falls between. Okay, the lowest 75% is 25, 25, 25. Those fall between 10 and 20. Tommy says that the interquartile range contains about 25% of data. Is he correct? So again, the interquartile range is the box. Does the box contain about 75% of the data? No, the box contains about 50% of the data. So Tommy is incorrect. The IQR is about 50% of the data. Feel free to pause this if you need more time to write down the statement, because I'm going to go to the next slide. Okay, same box and whisker plot. I need you guys to label each quartile as 25%. On Tuesday, Esther watched 13 videos. So let's find 13. And that's how many videos she watched on Tuesday. So I'm going to make a little star right there for 13. Circle all that apply. Tuesday was in the lowest 50%. Here's the lowest 50%. Was Tuesday inside the lowest 50%? Yes. So we're going to circle that one. Tuesday was in the middle 50%. Here's the middle 50%. Tuesday's not in there, so we're not going to circle this one. Tuesday was in the highest 75%. Here's the highest 75%. Tuesday's not in there, so we're not going to circle that one. Tuesday was in the lowest 25%. Here's the lowest 25%. Tuesday is within the lowest 25%, so we're going to circle this one. Tuesday was less than the median. Here's the median. The median is 16. 13 is less than 16, so we're going to circle that one. Tuesday was the median. No. So only these three will be circled. Okay, new box and whisker plot. The data below represents the ages of children living in a neighborhood in Webster Village. The youngest child is, that would be the minimum of 1 year old. And the oldest child is, that would be the maximum of 14 years old. The range of ages is blank. So when we say range, we're talking about the distance between the minimum and the maximum. This is the range. So I would do 14 minus 1, and I would get 13. The IQR of ages is, okay, when I say IQR, I'm talking about the distance between Q1 and Q3. So this is the IQR. So I'm going to do 11 minus 3, and I get 8. Jake says that the range is always bigger than the IQR. Is he correct? Well, looking at the box and whisker plot, the whole range is always going to be bigger than just the box. So we're going to say yes. The distance between the minimum and the maximum will always be more than the distance between Q1 and Q3. Please pause the video so that you can make sure you write this down, because I'm about to go to the next slide. Okay, please write 25% on each quartile of the box and whisker plot. The first question says, the youngest 25% of children are between ages blank to blank. Okay, here's the youngest 25% of children. They're between ages 1 to 3. So we were going to write down 1 to 3. The middle 50% of children are between ages blank to blank. Okay, this is what makes up 50% of the data in the middle. It's the interquartile range. It's the box of the box and whisker plot. And those kids are in between 3 years old and 11 years old. The oldest 25% of children are between ages blank to blank. Okay, the oldest 25% would be this Whisker, and they're between ages 11 to 14. The oldest 75% of children are between ages blank to blank. The oldest 75% of children makes up 3 quartiles at the right. They would be between ages 3 to 14. All right, please label each quartile as 25%. Michaela is 7 years old. So here's Michaela. She is 7 years old. Circle all that apply. Michaela is in the youngest 25%. No, because the youngest 25% is this Whisker. Michaela is in the oldest 25%. No, because the oldest 25% is this Whisker. Michaela is in the youngest 50%. The youngest 50% would be these 2 quartiles, and Michaela is not in those quartiles. Michaela is in the oldest 50%. The oldest 50% would be these 2 quartiles, and Michaela is in those quartiles. So that's the first thing we're going to circle. Michaela is in the middle 50%. The middle 50% would be the box. Michaela is in the box, so we're going to circle that one. Michaela is the median age. The median age is 5. Michaela is 7, so I'm not going to circle that one. Michaela is older than most of the neighborhood children. Since Michaela is in the top 50% of data, and I can tell she's older than at least half the children, I'm going to say that Michaela is older than most of the neighborhood children. This data shows how many minutes it took Bob to drive from Webster to Batavia on 7 occasions. Find the 5 boundary values, then make a box and whisker plot on the next slide and answer the questions. Okay, the first thing we have to do is put these numbers in order. So which one's the smallest number? 46. Which one's next? 48. Which one's after that? 50. And then 52. And then 58. And then 66 and 68. This is the minimum. This is the maximum. The next thing we're going to do is we're going to find the median, or Q2. So let's cross them off on either side. All right, here is our median, or we could say Q2, which is 52. Now we're going to split the data in half. And since there's an odd number of data points, you leave out the median. Okay, now we're going to look at the lower half of data and find Q1. All right, Q1 is 48. And now we're going to look at the upper half of data and find the median of the upper half, which is Q3. Q3 is 66. So these are the data points that we're going to bring to the next slide and make a box and whisker plot. So now that we're on the next slide, let's copy over our 5 boundary values. We said the minimum was 46. Q1 is 48. Q2 is 52. Q3 is 66. And the maximum is 68. Now let's float those points over a number line and make our box and whisker plot. 46 is the min. 48 is Q1. 52 is Q2. 66 is Q3. 68 is the max. Then you're going to make a box going from Q1 to Q3 and draw a line down Q2 to mark the median. And then you're going to make your whiskers. Let's label each section or each quartile as being 25% of the data. It took Penny 50 minutes to make the drive. 50 minutes. 50 minutes would be like right here. Was her trip faster or slower than most of Bob's trips? Well, Penny made the drive in 50 minutes, which means she was faster than about half of Bob's trips. These are pretty slow times compared to 50 minutes. So Penny was actually faster than most of Bob's trips. So I'm going to say faster. 50 minutes is less than the median. Penny's trip is in the circle your choice. Shortest 25% of trips, middle 50% of trips, or the longest 25% of trips. The shortest 25% of trips would be in here. She's not in there. The longest 25% of trips would be in here. She's not in there. She is in the middle 50% of trips. Okay, here are the ages of employees at Chase Bank. Please pause the video, try this out, and then unpause the video to see the answers. All right. The first one says the percentage of employees under the age of 48. So here's 48. The percentage of employees under the age of 48 would be 3 quartiles. So the answer there would be 75%. Okay, let me erase that. The percentage of employees over the age of 38. Over the age of 38 would be these 2 quartiles. So it'd be about 50% because each quartile is 25%. So that'd be 50%. The oldest employee is right here, the maximum, which is 52. And the range of employees is, okay, so the youngest is 20 and the oldest is 52. So you have to do 52 minus 20 and you get 32.